Hi, thanks for tuning in. Today I'm going to show you how to make random people. And we're going to make them as if they are stored in a database, but they're not really going to be stored in a database. It's just going to look like that. I'll show you what I mean. So let's get a random person. And here we see that we have a person with a particular ID, just as if they're a record in a database. But they don't have any attributes. So I only get those attributes once I look at them. So by converting that person record to a hash, it forces all of the attributes to be loaded. And here we see we have a toddler. So I might try that until we get someone. So here we go. We've got a senior married female. You can see that she has a spouse, and that spouse also has an ID. So that means we can query her spouse. And if we do that, we see that we get her husband, who has the same last name and the same address. But these records don't exist in the database. They're just generated on the fly using a random number generator. So how can we make sure that we always get the same person and we get the same relationships between people, even though we're not storing anything in memory or in a database? So I'll show you how I do that. I can begin by showing you how that record is defined. So here we have the person table, and they have a bunch of attributes. So there's age, marital status, sex, first name, last name, and occupation, and address as well. And all of these attributes are randomly generated, but they also have some structure. So for example, we know that the age is can take on one of these 6 values, and we know that each of these values has a probability of occurrence. So young adults occur just over 20% of the time. That's really good. Seniors occur about 14% of the time. These percentages are all taken from the 2011 census of the Australian population, which is why, if I were to count the number of records, I've actually just used 21.5 million people, which were the results of that census. So what we do is for each person in the population, there's an ID from 0 to 21.5 million or whatever. But we divide up those ID ranges into toddlers, children, teenagers, according to the probabilities for each of those categories. And then each of those categories gets subdivided with marital status, and then they get subdivided by gender. So I'll show you what I mean by doing a query. So like I showed you just then, I can count the number of people in the entire population. But if we had a look at that person that we generated, that was a senior female that was married, we can do that same query. So a female, and the age was senior. I'm having a good day with typing. And if we counted those results, we immediately get it's just over 1.1 million people of that category, and we got those results instantly. Now, how did that happen? Well, if we had a look at the query for all people in the population, the query itself just contains a range of IDs. Now, if we had a look at this query here, we can see that the range is much smaller. And it's because of that subdivision. All of these IDs are going to be married, elderly, female. A way of having a look at that a little bit more easily is if we were to query just females, then we can see that the query contains a range with, I think, about 10 different ID ranges, because one ID range will be infant unmarried females, and then one ID range will be adult unmarried females, and one ID range will be adult married females, and so forth. So basically, when we're generating the age column, we look at the ID, we find out which of these categories it is, and then we call a little bit of code that then generates a numerical age at random that makes sense for the category. And we do similar things for the other columns. For marital status, it's a little bit different. because what we do is we have multiple different versions of the statistic for marital status that depends on what the age of the person is. So a toddler can never be married, whereas an adult is married with a 61% chance. First name is interesting because when we're randomly generating your first name, we have a look at whether you're male or female, and then we give you a male first name or a female first name using this faker library that just gives you something at random. But what happens in this case is the random number generator is seeded with your ID, with the record ID, so that you generate the same name for the same record every time that we run the program. The last name is interesting because we have a look at whether you're a female, and then if you are, we have a look at whether you have a spouse. And if you do, then you take the last name of the spouse, otherwise you generate your own last name. And that's about it. Then all we do is we create a database instance with a seed. So the same database with the same seed will always have the same contents. And then we add our person table and we specify how many records we want to simulate. So the other thing that we can do, apart from querying, is we can iterate over records. So for example, I can find a person by their first name, for example. So my first name is Jason, so let's have a look at whether there's anyone with the same first name. And you see that after a short while we do get a record. Let's see what he looks like. So that's Jason Wyman as a toddler. So you can see that that was the 5,000th record or so. So we had to iterate over all records, generating just the first name each time. So we can benchmark that and see that it took just over 1 second to iterate through all those records. If I was to force all of the attributes to be generated first, then obviously it ends up taking a lot longer. So we're being lazy in the sense that we only generate the attribute when it's accessed. I have no idea why that's taking so long. I presume because I'm recording a video at the same time. So that took 20 seconds to do. So it's a lot faster just to generate the attribute when it's needed. So the other thing that I can do is I can filter. But of course that's going to iterate through all 21 million records, so we don't want to do that. So what we can do is we can just take the first 5, but it only makes sense. We don't want to iterate through 21 million records and then take the first 5, so we have to make sure that that's a lazy iterator. It will only generate the first 5 records. So we can see here that after a couple of seconds it's found us 5 records of people that have the first name Jason, and the highest record there was almost the 15,000th one. And we can see that that indeed is the person with first name Jason. Now you might be wondering how, if we go back to our original person, how they could have a spouse. Well, we do that with a relationship, and I sort of skimmed over that before. So this association between two people is done in the following way. We have one query to say, give me all the married females, and that's going to give me a range of IDs. And then another query says, give me all the married males, and that's the query that you were joining to essentially. And what you do is you find your ID within the first query, and then you find the corresponding ID within the second query. So the first married female in the population is going to be married to the first married male in the population, and so forth. And that way we can programmatically figure out the ID of your spouse without having to iterate through records or store anything in memory. So that's what I've been working on over the last couple of weeks, procedural generation of random people. Hopefully that was interesting. If not, don't subscribe to this video.
Yeah!